I've decided to make some videos here so that you can get a good understanding of the normal distribution. So I'm going to be working through some questions here with various type of questions. So I'll start with the basic normal distribution question here. Okay, so we say that the first thing we always realize about a normal distribution, is the mean and the standard deviation. So the distance traveled to work is the variable now over here and defined as d, and you can see the mean over here. The mean is 30 and the standard deviation is 8. The standard deviation sigma, it's not written very well over here. So standard deviation sigma is 8. So the question here is asking us to find the probability that a person or the employee selected at random walks more than 20 kilometers. That means you're looking for the probability that d is greater than 20. And how do we do this probability over here? We say that since we're going to use tables, we change this into a standard number, which is the z. So now the variable which was d now is changing to the standard number, which is z, greater than. We standardize the distribution, which is going to be 20 minus the mean, which is 30, over the standard deviation, which is 8. That's how we standardize. Remember the formula for standardizing, which is z equals to x minus mu over sigma, which is the standard deviation. So when you standardize over here, what you have probability that z is greater than, when you press your calculator, you see it's going to be negative 1.25. So this is your z value. Now all you need to do over here is to go on the z tables and try to read out the probability. I have my graph over here. I want to try to visualize this. So remember, it is a z. It's now with z, the standard normal. Our mean is going to be 0. So the value like negative 1.5 will be somewhere over here in the negative direction. All right. This is what you have. Negative 1.25 is over there. And you're looking for the greater than. Greater than, it means that you're looking for this area over here. But as we said, because of symmetry, I'll use another color over here. Because of symmetry, we can see that that same area here is the same as having the positive one, 1.25, and we have this area over here. All right, that means this area is the same as getting the probability that z is less than the positive 1.25. That's the area, the real area. If we can do it over here, that's the probability. If this is 1.25, the same probability as this one over here. So we go in the z table. The probability, this probability, when you go in the z table, you see that this probability is noted as phi. So it's noted as phi what? Phi z. That's the probability of z less than that given value you're looking for. So you're looking for phi of 1.25. And the answer over here, when you go on the table, I will go on the tables over here. So when you go on the z tables over here, you see that I'll try to annotate over here. You see that 1.5. Let me try to annotate here. When you go on the z tables, you find your z over here. This is the z value, and this is the probability of the z value over here. So our z value is 1.25. 1.25 is over here, and then look for the probability, which is 0.8944. That's going to be our probability. So from the z tables, our probability is going to be 0.8944. That will be the answer. So you can see the most important thing over here, we change the d into a standard normal, and after change the standard normal, you go and use the z tables and you find a probability. Only that you are supposed to do. I'm drawing the diagrams over here just for you to visualize it. But if you can do without the diagram, if you master it, you don't need to do all this working out. When you master it, you need only a few steps over here, not all of this, because you can summarize all these steps. All right, next question. All right, the next part of the question here, they're asking us to find the upper quartile, exercise 3. The upper quartile, we know that or the upper quartile of D. Now, for any value which is the upper quartile, probability that D, any value of D is less than the upper quartile, that is Q3, should be equal to 0.75, because the upper quartile is always 75% of the data. That means we are going to look for the value of Q. If we go on our table over here, that the value of Q is the value which is over here, Q3, that this area for this value Q3 should be 75%. That means they have given us the probability. We have to find the Q3. But how do we do this? What we need to do first, we need to find the Z value that gives us this probability. So we find the Z value that gives us this probability, or what we shall call like the inverse normal. That means we're looking for the Z value, which we call the phi inverse. The phi inverse, so I'll write it properly over here. The phi inverse, you're looking for the phi inverse of 0.75. And what does Z value? Or you're looking for the Z value, say the probability that Z is less than that Z value you're looking for is equal to 0.75. You're looking for the phi inverse because they've given the probability, but we only find the probability using the Z value. So we go and find the phi inverse of 0.775. We go on our tables now. When you look at the tables over here, I've been given the probability. That's the phi over here. So I'm looking for the Z value over here. So I'm looking for the phi inverse. So I come in these probabilities over here and I look for the value, which is the 0.75. So when I look over here in these probabilities, 0.75 is somewhere over here, is in between over here. So you can see these values over here. These are the values which are closest to 0.75. But I'll take the value which is the more closest, and that value will be 0.67. You can see this one here is just 14 off 0.75, but this one is all 17 above 0.75. So the closest one is this one over here. So I'll take 0.6. That means my Z value is 0.6. All right. So for my tables, the Z value here that gives a probability of 0.75, that Z value is 0.67. So this is the Z value that gives us this probability of 75%. And that means when you standardize this Q3 over here, when you standardize it and you have your Q3 minus the mean, which is 30, over the standard deviation, which is 8, the answer should be the Z value, which is 0.67. Then you can do the mathematics over here, and then you come up with your Q3 as your Q3 will be 35.36, like that. All right, because here they have given you the probability, so you find the Z value, you find the inverse of that probability, then you get the Z value, and then you try to go backwards how it was standardized to come up with that Z value. All right, part C now. Now the next part over here, part C over here, we are finding the Q1, but we know Q3 is 75% and Q1 is going to be, or is always 25% below. But what we know that this is 25% as well below the midpoint or the median or the mean, and is also the Q3 is 25% above. That means technically the Q1 and the Q3, they are symmetrical. And if our value of Q3 is 35.35, how far is it from the mean, which is 30? So how far is it from the mean? It is only a plus 5.36. It means that this distance over here is 5.36. Therefore, our lower quartile, we don't need to do any calculation. All we need to do is to go also below the mean, 5.36. That means our Q1 over here is going to be equal to 30 minus 5.36 because it is symmetrical. If this Q3 is 5.36 above, Q1 is 5.36 below, and then your Q1 over here, when you subtract, you have your answer as your Q1 as 24.6 what? 0.64, like that.